Howdy, howdy, howdy. I'm just madly scrolling through this big fat work booklet. We're on lesson 5. And guess what? That's the last lesson of this geometry unit. So hip, hip, hooray. Our objective on this one is develop and apply the formula for the area of a triangle. Warm up. Formula to find the area for a rectangle is, you know what? I'm going to let you guys pause this. I'll let you guys just answer these questions just to warm up your brains. So in 3, 2, 1, I'm going to answer all these. 3, 2, 1. The area for a rectangle, of course, is area is equal to base times height. And hey, check it out. It is for parallelograms as well. And something I failed to mention in our last video is that a rectangle, pretend that's a rectangle, and a parallelogram, pretend that's a parallelogram, they're both the same type of shape. They're both quadrilaterals. And this formula, area is equal to base times height, I can find the area of every quadrilateral using this formula. So boom, there you go. And then lastly, use the appropriate formula to find the area for the shapes below. So that's going to be area is equal to base times height for both. So I'm sure you guys wrote down your formula first because that's an important part of showing your work. Keeps us organized. I'll do this guy here first. So I can see that its base is going to be 7. And I know that the 7 is the base, not the 5, because 7 is forming a right angle with the height. 5 is an important side, but it's not forming a right angle, so I don't care about it for area. And then, of course, 7 times 4 is 28. And since there's no units, I'm just going to go U2. That stands for units squared. Okay, cool. Over here, same idea. Area is equal to base times height. Whoa. Sorry. I'm struggling here. Sorry. Area is equal to base times height. Okay, and this one's a lot easier because it's a rectangle. Our base and our height are already forming a 90-degree angle, so that's just easy. I know it can sometimes be a little tedious showing your work like this, but it's really important. Not only is it keeping you organized and therefore minimizing your chance for making mistakes, but it allows other people, including your teacher, to be able to go through your work and review every single operation and all your steps. And if you made a mistake, we can pinpoint where your mistake is. So it's important to have your formula, show your work. Anyhow, that's your warm-up. I'm sure you guys did that in a second because we're experts at it by now. And moving on. So triangles. Finding the area of a triangle is no different than finding the area of a rectangle or a parallelogram. You need to multiply the base by the height. So that's awesome. Now you may be thinking, cool. Area is equal to base times height. It worked for rectangles. It works for squares. It works for parallelograms. So it just works for triangles. Easy peasy. Not quite. Not 100%. So I want to remind you all the way back to our angles unit. Okay. So if you think back to our angles unit, we've got quadrilaterals and we've got triangles. If we added up all 4 angles in a quadrilateral, how many degrees would that be? You may be yelling at your computer screen right now. That's 360 degrees. Yeah, awesome. If you remembered that, good on you. You're right. All 4 angles have to add up to 360 degrees. How about inside a triangle? Well, they're not 360. All 3 of these angles will add up to 180 degrees. Now, I want you to notice what's the relationship between this number and this number, 360 to 180. If we set that up as a ratio, we can actually have a better look at this. So 360 compared to 180, what's the ratio? Well, I noticed that that's 360 is double 180. Or in other words, 180 is half of 360. It's a 2-to-1 ratio. Okay? So triangles are half quadrilaterals in terms of our angles. So 360 degrees for quadrilaterals, half of that is 180, and that's what triangles have. Now, how the heck does that apply to what we're doing now? We're talking area. How does that apply? Well, triangles are still half of quadrilaterals. All quadrilaterals can be cut in half. And when they're cut in half from diagonal to diagonal, what do we have? We got a triangle and a triangle. Like, check this out. If I just drew this guy here, half of that quadrilateral is a triangle. So triangles are half. They're half. Now, how the heck does that change our formula? Well, My quadrilaterals formula for finding area is base times height. For triangles, we said that they're half. So let's half it. Divide it by 2. Base times height divided by 2. That's your triangles formula. And that's it. Now, just like we learned with parallelograms, height and base, they have to form a right angle. So check this out. This triangle doesn't have a right angle in it. So we have to choose the base, go from right at the very tippity top all the way down, forming a right angle. We've got base and we've got height. So let's just solve this quick. In for my base is going to be 11. In for my height is going to be 5. I know that's the height because it's forming a right angle. And then divide by 2 just gets plugged in. Next step. Now we've got 2 operations here. We've got multiplication and division. We got to think back to BEDMAS. Well, what letter comes first? Well, D does. But when you have something set up like a fraction like this, we have to pretend that there's a big set of brackets around it. And what comes first in BEDMAS? Well, of course, brackets do. So I'm going to do the very top of the fraction first. So 11 times 5, yep, that's 55. And divide by 2 just drops down. And my last operation is the division finally. 50 divided by 2 is 25. 5 divided by 2 is 2.5. 25 plus 2.5, yep, that's 27.5 or 27 5/10 meters squared units. Got to circle my answer. Boom. And really, this process is exactly the same as what we've been doing finding the area for our quadrilaterals. The only difference is that we have that extra step of just dividing it by 2. That's it, because triangles are half of quadrilaterals. So your formula is area is equal to, and you're going to write this down in your notes too, of course, just so you have something good to study. Area is equal to base times height divided by 2. Let's do another example here. This guy here, find the area. Well, start with your formula. Area is equal to base times height divided by 2. A drops down. What goes in for my base? Well, 10 does. What goes in for my height? 6 does. Divide by 2 drops down. Next step. I'm going to do the top of the fraction first. 10 times 6 is 60. Divide by 2 drops down. I'll put my math up here. Area is equal to 60 divided by 2, of course, is 30 centimeters squared. Thank you for being neater than me. Yikes. Okay, moving on. So, important question. Why does this work? Why does going area is equal to base times height divided by 2, why does that work? Well, we've kind of already explained that a little bit. Remember that all quadrilaterals are just 2 triangles, right? Triangles are half of quadrilaterals. And this diagram here can help show us that. So we've got this yellow triangle inside this rectangle here. So all this space, I mean, like if we chop this triangle in half, right where we have that height line, we'll check it out. This yellow part is half of this quadrilateral. Same thing there, right? It's half and half. Triangles are half of quadrilaterals. That's something that's important. Like, hey, look, there it is right there. You might want to underline that or highlight it or whatever. Something you should know. Triangles are half of quadrilaterals. Okay, so with that knowledge, you're set to crush assignment 5. Okay, formula for area of triangle. We should have that. I'm gonna give it to you. Why not? Base times height. That's a rectangle. That's a quadrilateral. We got to divide it by 2 because triangles are half of quadrilaterals. So the only thing I'm going to say before I turn you loose is this. Don't let these triangles that have all these side lengths confuse you. Don't think, hey, 9's my base and 4 is my height. It can't be because it's not forming a right angle. You have to look for the right angles. So where's my right angle? I see a little square here. 3 must be my height. 9 must be my base. There it is. How about this guy? Do you see a right angle? This isn't. This isn't. This is. So base, height. Okay. Have fun, guys. Good luck. Smell you later.